Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to find out the bending stresses. So there is one numerical problem in which we have to find out the maximum bending stresses for a beam. So the problem states that a simply supported beam 300 mm wide by 400 mm high and 10 meter long is subjected to a concentrated load of 8 kN at a 0.4 meter from one of the supports. So this is a simply supported beam with a total length of 10 meter and there is a concentrated load of 8 kN acting at a point from one end of the support at a distance of 4 meter while the other distance is 6 meter. And determine the maximum bending stresses in the beam. So we have to find out the maximum stresses for this beam. And this is the cross section of the beam where the width of the beam is 300 mm and height of the beam or thickness of the beam is 400 mm. So to find out the maximum bending or the flexural stresses, we can use this formula to find out the maximum stresses if B maximum is equal to the MC over I. Now this is maximum bending stresses, so M correspond to the maximum bending moment in the beam. So M is the maximum bending moment in the beam and we have to find out this maximum bending moment for this beam. And C is the distance from the neutral axis of the beam. If this is the neutral axis of the beam, so C is the distance from the neutral axis up to the extreme fiber of the section. So it is the distance from this neutral axis up to the extreme fiber. So this distance is known as C. It means C is equal to the h by 2. Let's suppose this is h, height of the beam or thickness of the beam. So it is half of the thickness of the beam. So it is equal to the 400 mm. If we convert this into meter, so it will be 0.4 meter divided by 2. So we got here, from this value, we got here 0.2 meter. So this is the C for this formula. So this is the value of the C. Now, what is I? Where I is the moment of inertia for this beam, and we can find the moment of inertia by using this equation BH cubed by 12. Because it is a rectangular beam, so we can find out the moment of inertia by this formula. If it was a circular beam, then you have to use the moment of inertia of circular beam. But this is a rectangular beam, so we can use this formula where B is the width of the beam, which is 300 mm, and H is the thickness of the beam, which is 400 mm. So we can use these values in terms of the meter. So it will be 0.3 meter multiplied with the thickness height, which is 400 mm, or we can say 0.4 meter divided by 12. I'm using all the units in meters. So it is equal to the 0.0016 meter raised to the power 4. So this is the moment of inertia for this beam. Now the only unknown is to find out the moment for this beam, and for this we have to find out the support reactions and to draw the bending moment diagram and to find out the maximum moment for this beam in order to find out the maximum bending stresses. So to find out this maximum moment, let's consider this support is A and this is B, and we have to find out first of all the support reactions. It's RA and this is RB. And let's consider we use this equilibrium equation, the summation of moment at point B equal to 0. And clockwise moment is taken as positive and anti-clockwise moment is taken as negative. So RA will create the moment here in the clockwise direction about point B. So it will be RA into momentum. So momentum is this distance from A up to B, which is 10 meter here. And then this load also creates a moment about point B in the anti-clockwise direction about point B. So it will be taken as negative. So it will be minus 8 multiplied with the momentum. The momentum is the distance from the 8 kilonewton point up to point B, which is 6 meter. So summation of all the moments is equal to 0. Now 10 RA is equal to the, here if you multiply these two values, we got here 48. So RA comes out to be, if we divide this 48 by 10, we got here 4.8 kilonewton. So this is the support reaction here at this point RA is 4.8 kilonewton. Now to find out RP, we can use this equation that summation of all the vertical forces equal to 0, and let's suppose the upward force is taken as positive and the downward forces are taken as negative. Now RA and RB are acting in the upward direction, so it will be plus RA and plus RB minus 8 because it is acting in the downward direction equal to 0. Summation of all the vertical forces equal to 0. So, and from this equation we will get that RB is equal to the 8 minus RA, and we know that 8 minus RA is 4.8, so it comes out to be 3.2 kilonewton. So RB comes out to be 3.2 kilonewton here, 3.2 kilonewton. Now we find out the support reactions for this beam. Now we can draw the reference line for this beam. So this will be the reference line, and from this we can draw the shear force and bending moment diagram. So this is for the shear force diagram in the unit of kilonewton, and this is for the bending moment diagram in the unit of kilonewton meter. So now the first step will be that these are the reference line 0, 0, and we will start the shear force diagram from this end. So the RA is acting upward in upward direction with a magnitude of 4.8 kilonewton. So I will bring this point from 0 up to 4.8 kilonewton. Then there is no load on the beam, so it will be a straight line. And then there is a force 8 kilonewton acting in downward direction. So 4.8 was positive and 8 is acting downward, so it will be negative. So if we subtract the 4.8 minus 8, so we got minus 3.2. So here will be minus 3.2. And now again there is no load on the beam, so it will be a straight line. And then there is a load of 3.2 acting in the upward direction. So this is minus 3.2, it is plus 3.2, so it will bring this up to 0. So this is the shear diagram for this beam. This is plus shear box and this is minus shear box. Because this is above the reference line, this is below the reference line. Now from the shear boxes we will find out the bending moment. So the area of this shear box will be the bending moment value. So this is the height of the shear box, 4.8, and the base is 4 meter because this is 4 meter length. And this is 4.8 kilonewton. So this will give us the bending moment value. So the area will be, let's suppose this is A1. So it will be 4.8 into 4 meter. Because this is a rectangle, so we find out the area of this rectangle. So it comes out to be 19.2 kilonewton meter. So this is the area of this rectangle. It will be positive because it is in the upward direction. So the bending moment will also be positive here, and it is 19.2 kilonewton meter here at this point. Now the area of this rectangle will be A2, let's suppose. So A2 will be equal to the height of the rectangle is 3.2 minus 3.2 multiply with the base, which is 6 meter length. So this length is 6 meter, multiply with the 6. So A2 comes out to be minus 19.2. So this was plus 19.2, this is minus 19.2. So if we subtract from plus 19.2 the minus 19.2, so it will become 0. So we got 0 bending moment here at this point and at this point. So the maximum moment for this beam is 19.2 kilonewton meter. So this is the maximum value of the moment is M. So we found out the maximum value of the moment is equal to the 19.2 kilonewton meter. Now we have all the values for this equation. Let's suppose this is one equation. So we have all the values. We have just to put all the values in this equation. So we will find out the maximum bending stresses. So it will be equal to the FB maximum equal to the M, which is 19.2, multiplying it with the C is 0.2 meter, dividing it with the I, which is 0.0016. So by multiplying and dividing, we got the bending stresses of 2400 kilonewton per square meter. Because it is a stress weight, we will get the unit of kilonewton per square meter. It is the unit for the stress. Now if we divide this by 1000, so we will get 2.4 meganewton per square meter, or we can say 2.4 megapascal. So we have the maximum bending stresses in this beam is 2.4 megapascal, and these maximum bending stresses will lie at this point of the beam here at the distance of 4 meters from the hinge support. Hope you guys understand how to find out the bending stresses, and especially the maximum bending stresses were used to find out the maximum bending moment for your beam, and also this values should be from the neutral axis up to the extreme fiber in case of the maximum bending stresses. Hope you guys understand, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.